We'll go ahead and introduce ourselves, and then we're going to get started. So my name is Jeff DeMoss. I'm in product management for OpenShift AI.
My name is Michael Clifford. I'm a data scientist in the office of the CTO on the emerging tech team.
And I am Sally O'Malley. I am an engineer in emerging technologies office of CTO.
Fan club.
That's a good start.
All right, so before we talk about the Red Hat AI platform, I want to start off with what we're seeing in the market and what we're hearing from customers. So, first of all, GenAI is clearly a large opportunity. Just about every customer that we talk to is in some stage of evaluating it. And we're starting to see more customers move from POCs and pilots to production. But there are several issues that many customers are struggling with. The first is model cost. We see many customers struggling with the costs of running large proprietary GenAI models and model services, especially as they look to bring more use cases to production at scale. This was a driver for the work that we've been doing with IBM Research around the smaller, more cost-effective Granite open source models. Next is alignment complexity. So regardless of the model, many customers are also struggling with the complexity of aligning models to their private enterprise data and use cases. Some traditional model alignment approaches require specialized data science or AI skills. We wanted to make alignment more accessible to a broader set of users, and that's driven our work on InstructLab. And then third is deployment constraints. So many organizations are looking for the flexibility to be able to keep their proprietary data on-prem or wherever it lives for model tuning. In some cases, there can be regulatory or security requirements that might dictate their data needs. At the same time, as the number of use cases increases, they may need to deploy models across multiple clouds, on-prem, or even at the edge. And these considerations are driving demand for a hybrid AI platform. So overall, customers are looking for more cost-efficient models aligned to the use cases that they care about with the ability to run them everywhere. So these are the challenges that we set out to solve when we introduced RHEL AI earlier this year. RHEL AI provides a foundation model platform for GenAI development. It enables users to develop, test, and run large language models for enterprise applications. And now we're bringing RHEL AI functionality to OpenShift AI, including the Granite models and InstructLab distributed training. OpenShift AI provides an integrated MLOps platform to manage the model lifecycle at scale for both predictive AI and GenAI use cases. It provides a broad set of functionality across the AI lifecycle, including model development, training, serving, monitoring, a model registry, and automation for AI workflows. So the Red Hat platform includes RHEL AI and OpenShift AI, and now we're bringing them together in an integrated solution. Okay, so InstructLab provides model alignment tooling for customizing large language models. It allows users to submit knowledge and skills to tune a model, and it enables an iterative process for model customization. In the InstructLab community, this is how we take in contributions to our public community model. Enterprise customers can set up a similar process to customize their own private models with their own private data contributions. And this allows them to retain ownership of their training data sets and the model IP. So overall, InstructLab is a scalable, cost-effective method for customizing large language models, and it makes AI development more open and accessible to all users. Okay, so looking at alignment tuning across the Red Hat AI portfolio. First, InstructLab is an open source project that we introduced to help customers get started on their GenAI journeys. It serves as the upstream project for RHEL AI and also supports laptop usage scenarios. So users can try it out and experiment with small skill additions. In this sense, it's really intended more for demos and POCs rather than production use cases. So next is RHEL AI. RHEL AI is meant for production-grade model tuning with the InstructLab tooling. So you can add new skills and knowledge with custom data and then do full synthetic data generation, training, and evaluation using the iLab CLI. Now, if you look at how long it takes to do a typical end-to-end run, it's generally over 24 hours. So in reality, you're only looking to do a few in a given week. So that brings us to OpenShift AI. OpenShift AI provides capabilities to scale beyond a few models and provides significantly improved performance with support for distributed workloads. So with OpenShift AI, you can get support for more models, more teams, and this is where you'd look to productize InstructLab at scale. And then OpenShift AI also adds MLOps capabilities to manage the complete model lifecycle. Okay, with that, I'm going to pass it. I guess you've got me.
I have my mic. Thank you. So, Jeff, you've set up the work that Michael and I have been doing over the past few months very nicely, so thank you. How do you use this thing? Thank you. There we go. Michael and I have been running InstructLab on OpenShift AI. So we're going to show that to you, but before we do, let's deconstruct InstructLab and talk about the various components. First, you're a user that has your own data that you want to bring to the LLM. In order to do that, you'd have some documents, and the user would compile a short list of questions and answers that reference that document. Next step is to commit that to a Git repository. There's an upstream taxonomy repository to either fork or reference, and that's about it. Now, I'm going to pause here because the dream of InstructLab is to allow anyone to bring their own custom skills and knowledge to an LLM, but we all know that not everyone knows Git and YAML. So I just wanted to call out some of the cool work that some other people on our team are doing with creating a user interface with this really great project in GitHub called Dockling. Check out that project later. It was like a top trending project in GitHub last week. So that's going to abstract the Git and the YAML away from the data ingestion phase, but it's totally manageable. So once you have your data in the Git repository, the synthetic data generation phase pulls that down. And from each question and answer file, and with a teacher model, it generates a whole bunch of samples of questions and answers. I'm taking your seed questions and referencing the document. So the result is enough high quality samples to actually move the needle on a 7 or 8 billion parameter model. Now there's a lot more that goes into SDG. There's a LoRa adapter for the teacher model, some agentic workflows. So visit the Red Hat booth for a deep dive on all of that. But we'll move on to the next phase, which is training. So there's a phase training. There's a set number of epochs or run-throughs with the model, and using the tools that you might that you all maybe have heard of, like PyTorch, TorchRun, DeepSpeed, FSDP. So first, the skills data set is trained with a set number of epochs, and then the second phase, the knowledge data set is used, and with each epoch, a checkpoint model is then collected. So at the end of the phase training, you have a list of candidate models, and they move on to a model evaluation with MTBench. MTBench uses a judge model to evaluate each of those candidate models and figure out which one is the best. It does this. It's kind of like an SAT for models. It's a widely used model evaluation strategy with a set of standard questions. So the best performing model is chosen as your new custom model that knows all about your custom data. There's a final evaluation that happens there where the base model is compared to the new candidate model, and also each Q&A file is kind of judged and scored. So you have a full report of any regressions or improvements there. But there you have it. That's the complete run-through of InstructLab broken down. Now with RHEL AI, as Jeff mentioned, this all happens on a single machine. It's a single beefy RHEL machine. So with a handful of like high-end GPUs like H100s, A100s, this training can take a day or two, more or less depending on your hardware. But yeah, we're alignment tuning. We're not creating a whole new 8 billion parameter model. Like that's what takes the GPU farm in the data center, and that's what IBM does with their resources, and that's what's brought into Red Hat AI to use as the base starter models. And finally, what Michael and I have been working on is OpenShift AI. So again, the same workflow, same components, but with the phase training, you can distribute that across your GPU nodes. So with distributed training and some optimized networking for your hardware, this can really cut down on the time it takes to get to your custom model. Yeah, and besides the benefit of distributed training, OpenShift AI is a one-stop shop. There's dashboards for model serving that we'll see in a minute, and data science pipelines. There's evaluation tools and workbenches that are preloaded with all sorts of data science tools. Yeah, and beyond that, you've got OpenShift that is deploying all of your AI-powered applications. So it's really a one-stop place. And so yeah, if you want to know the details of all of the great new features in OpenShift AI, visit the Red Hat booth this week. I think I mentioned the model registry. If not, there's a model registry. There's all sorts of UX improvements happening, some storage updates. So come by the Red Hat booth. But I think now we're going to show you the distributed training pipeline. Before I do, we're going to show the model serving dashboard. So I mentioned that there you go. So we're going to show the video now. So I mentioned there's a critic model for the evaluation, and there's a teacher model for SDG. Here's a look at OpenShift AI, and from any, I don't think it's started yet. Yeah, you can start, yeah. So here's a look at OpenShift AI. Now, from any data science project, you can see the models tab, or over on the left, there's a model serving tab. And here we have our teacher and our critic model running via VLLM and Kserve. If you dive down, you can see the important information you need to make requests to this model service, the endpoint, the token. These are all backed by Kserve custom resources. So if you wanted to deploy your own model, it's as easy as clicking the button and filling out this form. So you'll choose from the list of serving runtimes. We always choose VLLM. And some other specs. It will tell you what accelerators are available to you. You can choose those. You can decide whether to expose your model service to the outside world with an external route, and if so, whether to use token authentication. The last step is to give the location of your model. For this, it's assumed that it's in S3 storage, and we use in-cluster S3 compatible storage, NUBA, or Red Hat Data Foundation. It works great, and that's another thing about OpenShift AI is that S3 integration is seamless. So now that we have our critic and our judge model, I'm going to hand it over to Michael to show the distributed training pipeline.
All right, great. Thank you, Sally.
Yeah.
Cool. So yes, so like we saw earlier, I'm not going to read that.
Okay.
In order to run the InstructLab process, you need to have judge-critic model served because we have OpenShift. We're able to do that kind of independent of our pipeline. So now those are set up, we can start to see what we have here. So start with the OpenShift AI dashboard, as we normally do. The first thing you're probably going to want to do is interact with the starter model, the Granite starter model, to see where it begins. Where does the life begin? What does it know at this point? So it's easy enough to go ahead and, again, just like Sally showed, but for this smaller model, serve it on one GPU in our cluster, fully set it up through the UI here, token authentication, all of that great stuff. Point it to the direct location in our S3 bucket, and we're off to the races. So now we have this chat application that we want to talk to.
Hey, Michael,
and
I forgot to ask the audience something. Can I use your mic?
Sure, go ahead.
How many hockey fans do we have out there? So it's a very special year for Salt Lake City. You all know that there's a new NHL team, the Utah Hockey Club in Salt Lake City, right? You know who didn't know? The Granite starter model. So we're going to fix that.
We're about to find out. Yes, so we want to know if it knows anything about this new hockey team. So we'll ask it, when did the Utah hockey team begin? And we see that it generates a somewhat strange answer about 2006, 2007. We know that's wrong. But that's obviously to be expected. This is the starter model. It hasn't been trained yet to really do much. So now we're at a good place where we know something that we want to teach our model. So now we can go ahead and use InstructLab to teach it about the Utah Hockey Club. So earlier on, Sally went ahead and created a fork of the upstream taxonomy repo and created her own branch for creating this data. So cool, so we can go over to the Data Science Pipelines tab here, and this pipeline that we have been working on for the last little while here is available. And this is how we are going to be able to run InstructLab. So this is what the graph looks like. It's somewhat complicated looking, but I swear it's more simple than that. But each of these individual circles essentially represents a pod that is run, that runs one step of the process. And so this is like the pipeline is fixed, but you can run it as many times as you'd like. And you can customize those runs, so we'll talk about that quickly here. So when you create a run, you're presented with this UI that's a form essentially that you can fill out to customize the run. So there is the experiment. You're going to want to keep track of the different experiments that you are using. You can give the run a specific name. Let's see what else. It's important to set the model that we're going to use. So here, this is actually an older field. It's not going to be using the instruct model, but actually the Granite starter model that we have stored in PVC. Then you're able to update some of the this InstructLab, the SDG, the training, the evaluation. These all have tons of parameters that can be tuned and optimized. So we expose them here for the user to update themselves. The one thing that's probably most important to share with everyone here is the nodes and processes per node. So this is where we're actually dictating how distributed we want our run to be. So in this case, we have 2 nodes with 2 GPUs per node. So this is basically going to be a 4 GPU distributed run where we're distributing both internal to the node and among the 2 nodes. And then here we're able to put in the Utah Hockey branch that Sally had generated for us and put in her fork of the taxonomy. The other thing too is we want to be able to use the agentic version of the SDG, so we are able to switch between the different types of SDGs. Now we're going to see the same graph again here, but this is a little bit different view. As it starts to run, it's going to start to animate so that we can see how all the different pods are behaving while this is happening. So let's see. So yes, these things will start to Put hourglasses, and you can actually introspect into what they're doing. You can see the input and output of the step, the details of the task, the volumes that we've attached to it, and like most importantly, the logs, right? So as it's running, you can actually look into the logs that OpenShift is exposing to it. So this step is downloading the GitHub data that we need for SDG. Again, we were supporting, or we're using a Hugging Face for open source models. So that's what's being shown here. And then we're moving into the synthetic data generation. The data processing, where we're tokenizing all of the data that we've synthetically generated. Then we have our PyTorch job that uses the distributed training operator to distribute the training. So that gets defined here. We can look at all of the details of that particular step. We do this a second time for the skills training, as Sally highlighted. Then it goes to running the empty bench to find the best candidate model we want to promote, and then finally final evaluation to do that, and then we push the model to S3 so that we can use it later. So that was just quickly to show you, this is a complicated looking graph, but those are the main hubs, let's say, of this node, and the rest of them are being used to handle data processing or storing artifacts that can be used later. So we're not going to sit here and watch this whole thing run because it would take hours, but I'll go ahead and just show you one that was already successfully run. So when we fully train our model, you'll be able to see this graph that's full of these really pretty green check marks that lets you know that everything's been completed. As long as the pods that are backing the steps are still available, the logs are there for the user to see. Not so useful when everything runs correctly, but when things break, this is very, very useful to have. So we can, again, introspect the logs after it's successfully run. But most importantly, we want to know where it's put our trained model. So we can find the address of the model that's been pushed to S3 here. And we can now deploy this and see if it's actually learned anything about the Utah hockey team. So again, instead of redeploying everything, creating a new model server, I can just go ahead and edit the existing one and then just change the location of the model path to this new S3 and redeploy it. This will take a couple minutes for it to download. So we're skipping that here. But once it's ready, we can go back to our chat application and ask it a question. We're going to ask it the same question that we did a few hours ago. And there you go. The Utah Hockey Club started playing in the 2024-25 season. So, yes. So we have successfully taught our model something that it didn't know when we started. And yeah, that's basically the demo of what we've done so far. If you want to switch back to the slides, that'd be great.
Yeah, I wanted to point out something else. So in the Ask an Expert session before, they were talking about, why would I go with OpenShift versus vanilla Kubernetes? And, it's because, and it's the same reason why you might go with OpenShift AI rather than go out in the currently wild world of open source AI and pull down your own stuff. Red Hatters are very tuned in to upstream communities. That's kind of what we're founded on at Red Hat. And so we always, we're tuned in, we always know which things are important to pull down and build internally and support. And those are the things that end up going into OpenShift AI.
Cool. So yeah, thank you. I think that's, if there's any questions or anything, we'd be happy to answer.
All righty. I think we might have a question there. Oh no, sorry. Hey, you can make up a question though if you like. Oh, brilliant. Thanks, Sam.
Many of the things that were shown here, right, they have a lot of parallels with things could be done using RAG also, right? I totally understand this was a demonstration to show how the fine-tuning can be carried out. So is this fine-tuning capability can be extended to any open source model like a Llama model, or is it confined to Granite models?
It is model agnostic. I believe it can run any upstream, any model, yeah.
Oh, okay. That's good to know. Thanks.
And RAG also applies here. The idea of infusing the data in the model, you don't have to go back and forth to the vector database. So, once the data is in the model, you don't need to do that anymore. But using RAG on top is always also a very good option, and we'll be doing that also.
Yeah, nothing here would preclude you from using RAG.
Okay. But does OpenShift AI has a mechanism to show what you showed through a pipeline, a RAG use case too?
If you would build it, yes.
We can help with that.
Yeah, so let me just be clear. So the pipeline that we showed you was something like we constructed, and we specifically decided to construct the InstructLab pipeline, but data science pipelines that's provided with OpenShift AI is like a generic tool that can be used for orchestrating any type of series of workloads that you want to do. So if you want to do a RAG-based one, I don't see anything precluding that from being feasible.
Yeah, and I would, sorry, I don't have the mic, but the pipeline that Michael and Sally showed, we are planning to have an out-of-the-box pipeline in the product that can be configured through admin settings in the first half time frame next year. So right now it can be brought in, folks can experiment with it, and then we're working towards getting it out of the box early next year.
Yeah, that's what I was discussing with Diego to see if I can get hands on whatever this was so that we can
Oh, yeah.
Yeah.
early adopters.
Yeah, definitely.
Yeah, and one of the things about all of these tools, so many parameters, so many flags, with our customers helping us use it, and we'll be able to show, like, which one should we expose? What should the default value be? Like, that was a lot of time and Michael's expertise that went into this.
Yep.
Okay, well, we've got one more question at the back there.
Thanks for the talk. A quick question on authentication. So is the OpenShift AI authentication sort of tightly bound to the OpenShift cluster login itself, or can we bring our own sort of authentication system to it?
Great question. Is it always running on OpenShift?
Yeah, it's always an add-on on top of OpenShift.
Okay.
It's built on open source tools, though, so you could use Kubeflow pipelines or VLLM. You could construct your own.
Fantastic. Let me get the mic there.
Well, what is the licensing model for OpenShift AI?
Oh, great question.
Yeah.
Yeah. You want to? Yeah. I forgot to mention that.
So for the self-managed product, this one works a little better. So we have the same units, the metric units that are used for OpenShift. So we have core-based pricing, we have bare metal pricing, and again, the same units that are used for OpenShift. It's essentially 50% of the price of OpenShift.